Coming to the second part of Bellman-Ford algorithm, in this session I would like to discuss the algorithm of Bellman-Ford and its time complexity. Now let us discuss the algorithm of Bellman-Ford's. So here in this algorithm I represented G as the graph and W as the weight and S as the source. So initializing the single source as G of S. For I equals to 1 to V of G minus 1. So V of G represents the number of vertices. So the number of vertices is equals to 6 minus 1, that equals to 5. So in this step we are going to relax the values. So this relaxation is repeated up to 5 times. So in this relaxation step we are going to update d of v. If d of v is greater than d of u plus w of u comma v, then we are going to update the d of v. That means if this value is minimum, we are going to update this, or else d of v is as it is. So after completion of these 5 steps in this for loop, we are going to take the edge values which are at the 5th step. So E of G represents the set of edges which are present in the 5th step. Do if d of v is greater than d of u plus w of u comma v. What is the use of this for loop means, by using these edge values we will check it will form a negative cycle or not. So for example, if I consider the vertex 5, the cost of 5th vertex is 1 and the source for 5th vertex is 4, so I consider it as u, and the cost of 4 is 0 and the weight of the edge is equals to 1. So this case is not true. So then we are going to return it as true statement. That means the edge value is true. When d of v is greater than d of u plus w of u comma v, we are going to print that it is a false edge value. So it will form a negative cycle and the edge value is a false one. So the particular graph is not suitable for finding the shortest path. Coming to the time complexity of Bellman-Ford's. So here in this graph we have 6 vertices. So here in this Bellman-Ford algorithm we are repeating the step number of times. That repeating of steps number is equals to v minus 1. So here we have the number of vertices equals to 6. So 6 minus 1 is equals to 5. So we are relaxing the values 5 times. After that we are getting the solution. So if we have e number of edges, so this e number of edges has to be relaxed v minus 1. So it will take the time complexity of e into v minus 1. So in order to represent the time complexity, we represent that order of e into v. Or else if you consider that e as n and v as n, then we can represent the time complexity as order of n square. So the worst case time complexity is order of e into v or order of n square. I hope you understood it. If you have any doubts, comment below and like the video and press the bell icon for more notifications. Thank you everyone.